In this tutorial, we are going to study about the interconversion of number systems, like converting the decimal number system into hexadecimal or binary or vice versa. So we can study it in two parts. In first part, we will study how to convert any base into decimal, like how to convert binary into decimal and hexadecimal into decimal. For this conversion, there is a common procedure. We have to convert any base into decimal by multiplying each digit by its positional weight and then summing all the weights together. For example, if you want to convert your binary number into decimal, then just note down that number and then multiply each bit by its positional weight and then add all the products together and you'll get the decimal equivalent of the given binary number. So this is the procedure to convert the binary number into decimal. First get the decimal number, note down your decimal number, then after that write the weights in the exponential form. The binary number system has a base of 2, so according to that you have to write down its positional weight and then place 1 and zeros at appropriate positions, that is place a 1 if weight is taken during the sum and 0 otherwise, and then add all the products together. Let me solve one example for you. The given binary number is 11011.01. I will take the fractional number so that you will understand that how to convert it for the fractional numbers as well. This is the given number. So we have note down the decimal number. Now what is the next step? Next step is write the weights in the exponential form. See, here the base of this binary number system is 2. So the weight of each digit will be like 2 raised to 0, then 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. Right? So here we can write this as 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus this is going to be 0 only, so we'll skip it, then 1 into 2 raised to, yes, 1 into 2 raised to 1 plus 1 into 2 raised to 0 plus, now for the numbers, for the bits which are after the fractional point, we have to take the weights as 2 raised to minus 1, 2 raised to minus 2 and so on. The first bit is 0, so we'll just skip it, then the next bit is 1, so it is 1 into 2 raised to minus 2. And then add all the product together. These are the products which we have got. You have to add all these products together. 1 into 2 raised to 4, this is 8 plus 2 raised to, sorry, let me erase this. 1 into 2 raised to 4 is 16, 2 raised to 3 is 8, 2 raised to 1 is 2, 2 raised to 0 is 1 plus 1 into 2 raised to minus 2. Actually this is 1 upon 2 raised to 2, or we can say this is 1 upon 4, and then we can say this is 1 upon 4 means this is 0. Yes, 0.25. This is 23. 16 plus 8 plus 2 plus 1 is 23. Point 1 upon 4 means this is 0.25. So your answer is 23.25. And we can write down the final answer like this. 11011.01 is equal to 23.25. This is given in decimal. Your question was given in binary and then you have obtained its decimal equivalent. Okay? So to convert any given binary number into decimal, first you have to note down all the bits, then after that multiply each bit by its positional weight. Multiply each bit by positional weight. And then if it is 0, then you just have to ignore it, or you can write 0 as well over there. And then for the numbers which are after the fractional point, means for these fractional numbers you have to take the weight like 2 raised to minus 1, 2 raised to minus 2, like this. See here, this is going to be 2 raised to minus 1, this is 2 raised to minus 2. This is 0, 1, 2, 3 and 4. So the weight for this one is 2 raised to 4. For this one it is 2 raised to 3. For this one it is 2 raised to 1. For this 0 it is, for this one it is 2 raised to 0. Okay? In this way you can convert the given binary number into its decimal equivalent. Now the same method is followed if you have to convert the given hexadecimal number into decimal. The only difference is that here the positional weight are in terms of powers of 60 because the base of the hexadecimal number is 60. Okay? So in hexadecimal number system, each digit position corresponds to a power of 60. The weight of the digit position in a hexadecimal number is as follows. In hexadecimal number system, each digit position corresponds to appropriate power of 16. The weights are like this: 16 raised to 3, 16 raised to 2, 16 raised to 1, 16 raised to 0, and for fractional numbers it is 16 raised to minus 1, minus 2 and minus 3. So to convert the hexadecimal number to decimal number, multiply each hexadecimal digit by its weight and then add the resulting products. Let me show you one example. I will take a blank PPT and then I will show it to you. We are studying how to convert a given hex number into its decimal format. Hex to decimal. Given hexadecimal number is 5b.2 and you have to find out its decimal equivalent. Now let us solve this. First we have to note down the number 5b.2. Then after that multiply each digit by its positional weight. For this weight, the positional weight is going to be 16 raised to 0. For this it is 16 raised to 1. For this it is 16 raised to minus 1. Now according to that, write down this: 5 into 16 raised to 1 plus b means it is 11, right? 11 into 16 raised to 0 plus 2 into 16 raised to minus 1, and then calculate the products and add the products together. This is going to be 80 plus 11 plus, this is 2 into 16 raised to minus 1. 2 into 16 raised to minus 1 is actually 2 divided by 16. And then if you calculate 2 divided by 16, it comes out to be 0.125. So this is 80 plus 11 means 91.125. And this is your answer. It means that 5b.2, which was given in hexadecimal, its decimal equivalent is 91.125. This is your answer. And you can observe that the method and the procedure is same for converting any other number system into decimal. You just have to note down all the bits, you just have to note down all the digits and then multiply each digit by its positional weight and then add all the products together. That's it, and you get the decimal equivalent of the given number system. Now the second part is that how to convert the decimal numbers into other. How to convert the decimal numbers into other. For this, we use the method of successive division. For the integer part, we use the method of successive division, and for fractional part, we have to use the method of successive multiplication. While converting the decimal number systems into binary or into hexadecimal, we need to follow two different methods for the integer part and for the fractional part. So let us study the decimal to binary conversion first. These are the steps in successive division method. First, divide the integer part of decimal number by desired base number. Then store the quotient and the remainder. You have to note down the quotient and remainder. Remainder will be noted on this side, on the right hand side. Then consider the quotient as a new decimal number and repeat the step 1 until the quotient becomes 0, and note down the remainders in the reverse order. Then you have to note down all the remainders in the reverse order, means from bottom to top. You have to note down the numbers from bottom to top. This is going to be the most significant bit and this is going to be the least significant bit. In this way, you can convert given decimal number into its binary equivalent, and this is called as the successive division method, because you have to divide that number unless and until your quotient becomes 0. ओके एंड देन जो भी क्वेश्चंस जो भी रिमाइंडर्स आपको मिले हैं दैट यू हैव टू नोट डाउन इन द रिवर्स ऑर्डर फ्रॉम बॉटम टू टॉप. This is going to be the least significant bit and this is going to be the most significant bit in the binary equivalent number. Now let me solve one example for you. We are studying decimal to binary conversion. And the example is 43. 43 is given in decimal and you have to find out its binary equivalent. For this we have to use the method of successive division. Note down your number as a quotient. Sorry, not a quotient, it is taken as a dividend, and then divide this number by 2. 2 twos are 4, then 2 ones are 2, so it is 21 and the remainder is 1. Here you have to note down the remainder. Then this is going to be 2 tens are 20 and the remainder is 1. Then 2 fives are 10, the remainder is 0. Then 2 twos are 4, the remainder is 1. 2 ones are 2, the remainder is 0. And then note down this last remainder like this. And then after that you have to note down this number in the reverse order, that is from bottom to top, and then you will get your equivalent binary number. So for 43 the equivalent binary number is like this: 101011. It is 101011. This is the equivalent binary number for the given decimal number 43. You can also cross check your answer. How? You know that how to convert this binary number into decimal. For that what we do, that we write down its positional weight like 0, 1, 2, 3, 4 and 5. And then by multiplying these positional weight with the numbers, we get our decimal equivalent. So here we can cross check our result. 2 raised to 5 is 32. Then 2 raised to 3 is 8. Then 2 raised to 1 is 2. 2 raised to 0 is 1. So 32 plus 8 is 40. 42 and 43 means your answer is correct. Okay? This way you can cross check your answer. This is how you have to convert your integer decimal number into binary. Then next part is how to convert the decimal fractions to binary. How to convert the decimal fractions to binary. For this, the successive multiplication method is used. Here you have to multiply bit by 2 and record the carry in the integer position and note down the integer in forward direction. After doing this for 5 times, you have to note down these integer parts in the forward direction, that is from top to bottom, and then you will get the binary equivalent of this fractional decimal number. For example, 0.364 is given. The 0.364 is to be converted into byte. And for this, we cannot use the successive division method. For the fractional part, we have to use the successive multiplication method. You have to multiply this fractional part by 2. And then after that, the answer is 0.728. From here, you have to note down only the integer part. Here the integer part is 0. Then after that, take out this 0.728 fractional part. Again multiply it by 2. The answer is 1.456. From here you have to take out the integer part. Then again take the fractional part 0.456, multiply it by 2. The answer is 0.912. From here we'll take the integer part, then 0.912 multiply it by 2, take out the integer part, repeat the same 0.824 multiplied by 2, the answer is 1.6428 and the integer part is 1. So we have got these 5 integer parts, and now you have to note it down from top to bottom, that is 0.01011. This is going to be the binary equivalent of the given number. Here the accuracy of that fractional number will depend that how many times you repeat this procedure. But you can repeat it only for 5 times, that much accuracy is enough. Okay? So you have to multiply each fractional part by 2 for 5 times, and then after that you have to note down the remainder in the forward direction, and then you will get the binary equivalent of the given fractional decimal numbers. For decimal to binary conversion, if it is integer, then you have to use the successive division method, and if it is fractional number, then use the successive multiplication method. Now the same method is used for converting the decimal numbers into hexadecimal. So as we have converted decimal into binary by dividing that number by 2 by using the method of successive division, here also we will convert decimal number into hexadecimal number by using the method of successive division. For example, 650 is to be converted into hexa decimal. For that we have to divide that number by 16. Then here note down the quotient and remainder. Again, take that quotient as a fresh hexadecimal number, again divided by 16. The quotient is 2, the remainder is 8. Then again take the quotient. Now here the quotient is 2, it is not divisible by 16, so the quotient for this division is going to be 0 and the remainder is 2. And then after that you have to note down these remainders in the opposite sequence. A8, you have to note down it in the opposite sequence like this. This is your MSB and this is the LSB. 28A, because 10 is represented as A in the hexadecimal number system. Let me solve one example for you. Suppose the given hexadecimal number is 352 and we have to convert this hexadecimal number. Sorry, this is the given decimal number and you have to convert this into hex. And for that we have to use the method of successive division. So take this 352 as the your decimal number and then divide it by 16. So 16 twos are 32, the remainder is 2, 22 so is going to be 22. and the remainder is 0. Then 16 ones are 16 and the remainder is 6. Right? So we have got only two remainders, that is 6 and 0. There is one more, that is 1. So 160. 160 is your answer. You have to note down these remainders in the opposite sequence. So 160 is the answer for 352. So using the same method, you can convert your decimal numbers into hexadecimal numbers. Now this is for integer part. Okay? If you want to do this for the fractional part, then you have to use the same method as we have studied for the decimal fractions to binary. The same method is used for the decimal fractions to hexadecimal. The only difference will be that here you will have to multiply these numbers by 60. Instead of multiplying it by 2, you will have to multiply it by 60. And in this way you can convert your other number systems into decimal or decimal into other. That's it for this tutorial.